Okay, question 12. This is actually kind of a fun question here. We're going to sketch the graphs of the first and second derivatives on the same grid. Okay, so to take the first derivative, now first of all, you look at this here, and I think we can all see this, that this is the basic shape of this is a cubic, roughly. I mean, I don't know that for sure, but that's what it looks like. So I know that when I take the derivative of it, the degree should drop to a quadratic. Now let's just take a look at a couple things. The slope of the tangent line is a 0 here, it's a 0 here, which means my derivative will go through 0 there and 0 right there. It doesn't look like it lines up exactly, so these are two x-intercepts for my first derivative. Now notice that all of the slopes along this section right here, to the left of that 0, all of those slopes are negative, which means to the left here, my graph should be below the x-axis. From this point to this point, all of the tangent slopes are positive. And notice what's going on here is the slopes are getting steeper and steeper until you get to about here. And then they start to get smaller and smaller again. So that means that our graph is going to go up, hit a maximum, and then it's going to start to come back down to that intercept. And then from this point on, from here over, all of the slopes along this line again are negative. So that means our derivative is going to drop down. And there you go. You can see the first derivative there. The second derivative, we apply the same sort of thinking, but we apply it to the first derivative. So this point right here is where the slope of the tangent to the first derivative goes to 0. So that's going to be an x-intercept. Okay. To the left of that point, all of these slopes are positive. And if you read this thing left to right, they're all positive and getting smaller. So really what that's going to be is a line coming down. And as we go to the right of that point here, all of the slopes are negative and basically getting like smaller, or if you want to think of it, or larger in the negative direction. And again, it's just going to go down like that. And which makes sense that the derivative, the second derivative of a cubic would be a linear function.